Hello, today I'll be covering proportions. Proportions are two ratios equal to each other. If we look at this proportion, 1/2 equals 2/4. Remember, ratios can be represented as fractions. So, in other words, a proportion is just equivalent fractions. Now, 1/2 equals 2/4 would be read as this as a proportion. 1 is to 2 as 2 is to 4. Now, example 1, what they want you to do is write the proportion in fractional form of this sentence. 2 ice cubes is to 5 beverages as 4 ice cubes is to 10 beverages. So that'd be 2. And I'll just write ice is to 5 beverages as 4 ice cubes is to 10 beverages. Now, something that's true about all proportions is something a cross product. So you can use a cross product to verify them. And what a cross product is where if you take the numerator of the first and multiply it by the denominator of the second, that equals the denominator of the first times the numerator of the second, or just this little cross product. That's why it's called the cross product, because you multiply across. And when you set it up, it would be A times D equals B times C. So for example 2, they want us to verify example 1. Just make it a little quicker. I am going to drop the units. So that means 2 over 5 equals 4 over 10 is the proportion. So the cross product would be 2 times 10 equals 5 times 4. Well, 2 times 10 is 20. Does that equal 5 times 4, which is 20? Yes. Since they are equal to each other, 2/5 equal to 4/10 is a true proportion. If they were not, then it is not a proportion because they aren't equal to each other. So example 3 wants us to determine if 2/5 over 2/7 is equal to 1/10 over 1/3. So to start off, I'm going to do the cross product. 2/5 times 1/3 equals 2/7 times 1/10. Now simplify both sides first. Can any of the numerators simplify with any of the denominators over here? No, because they're all prime numbers, 1, 2, 3, and 5. So you just multiply across. 2 times 1 is 2. 5 times 3 is 15. Now does that equal 2/7 times 1/10? First thing I'm going to do is, because I know 2 reduces by 2 by 1, and 10 reduces by 2 to 5. So you can do that in multiplication. You can reduce across. Now I'm left with 1 times 1 is 1. 7 times 5 is 35. And that can't be reduced. So are these fractions the same? No. And in case you, like, if you didn't simplify it all the way or something, you could even do another cross product here if you wanted. But both fractions are in the simplest form, and they aren't equal to each other, so it's not a true proportion. So, no. Now, why are proportions used? One way is because it gives us a quick, easy way to solve equations that contain fractions, because we can just use the cross product because it's a proportion. Now, like I said, this cross product only works with proportions, which means one fraction set equal to another fraction. That's the only time this method will work. So example 4 wants us to solve for x. So I'm going to start off with the cross product. X times 9, or 9x, because the variable usually does come last, and equals 3 times 12. Well, 9x equals 36, because 3 times 12 is 36. To solve for x, I have to get rid of the 9. Since I'm multiplying by the 9, I'm going to do the opposite, which is divide by 9. So x equals 36 divided by 9 is 4. So x equals 4. Now, on to b. Again, you're just going to start off with the cross product. 8 times x equals 1/3 times 24. To simplify the right side, I'm going to change 24 to a fraction. Now I can reduce. 3 goes into 24 8 times. 3 goes into 3 1 time. That means 8x equals 8 times 1 over 1 times 1, or just 8. To solve for x, again, the same step as up here, we have to divide by 8 because we're multiplying by it, which means x equals 1. Now on to c, which has decimals. The first thing you do is the cross product. 1.8 times 8.4. And x times 2.5, or 2.5x. So to multiply this, I'm going to do it off to the side. 1.8 times 8.4. Multiplying decimals, just multiply it normally, then count your decimal places. 4 times 8 is 32. Write down the 2, carry the 3. 4 times 1 is 4, plus 3 is 7. A placeholder 0. 8 times 8 is 64. Carry the 6. 8 times 1 is 8, plus 6 is 14. Add 2 plus 0 is 2. 7 plus 4 is 11. Carry the 1. 1 plus 4 is 5. 1 is 1. Add 1 decimal place here. Add 1 decimal place here, giving me a total of 2 decimal places. So 1, 2. So 15.12 equals 2.5x. Again, because I'm multiplying by 2.5x, I'm going to divide by 2.5 to get x by itself. Now, do this long division. 15.12 divided by 2.5. I have to move the decimal, which means I have to move it once here, and it goes straight above where it is. So straight up there. Does 25 go into 1? No. Does 25 go into 15? No. Does 25 go into 151? Yes. About how many times? 6. 6 times 5 is 30. 6 times 2 is 12. Plus 3 is 15, so 150. 151 minus 150 is 1. 12, because you have to drop down the 2. Does 25, I'm going to erase that because I'm going to be carrying some more. Does 25 go into 12? No, 0. And I'm going to add 2 more zeros to see where I go. Drop a 0 down. Does 25 go into 120? Yes, about 4 times. Well, 4 quarters is 100. When you subtract it, you get 20. Just drop down your 0 first. Does 25 go into 200? Yes. How many times? Well, there's 8 quarters and $2, so 25 goes into 200 8 times. And actually it comes out perfectly even. Subtract, you get a remainder of 0. So x equals 6 and 48 thousandths. And that is how you solve proportions. Thank you.